Hi, Mr. Keitlinger here with pre-calculus again. The date that I am doing this is August the 10th, 2017. Class will be watching this in October when I'm in Germany. And I'm going to be back next week. Okay, and the first one that says when I walk in the door, when you walk in the door, oh, you're back again. We like Mrs. Begeman better. I'm going to kick you right in the butt as hard as I can. And I mean it. Even if you do like Mrs. Begeman a lot better. Okay, today we're going to talk about finding the points of intersection. Okay, notice I have S in parentheses because there could be 1 point of intersection, there could be 0 points of intersection, there could be 2 points, could be 3 points of intersection. If we look over here, here is a parabola. Can you see me on the screen, Jessica?
No.
Jessica, pop out here once. Okay, she can be my pointer here. There's Jessica, my assistant, the producer and director. Okay, the top one of Jessica points at that. You can see her now, I think. Okay, there's an intersection of a parabola and a line, and they meet in 2 different points. Okay, my next picture right below that one. Okay, again, a line and a parabola. The intersection is just 1 point. Okay, or the one below that, there's a parabola and a line again. No points of intersection, that's possible. The one right below that, there we've got 2 parabolas. 2 points of intersection. Could be 1 point of intersection, could be no points of intersection. Why am I making hand gestures if I'm off camera?
Force of habit.
Force of habit. Okay, in the bottom one, there's a cubic equation and a line. There could be 1, 2, 3 points of intersection. Thanks, Jessica.
You're welcome.
First problem. And this shouldn't take too long today. Yay. Am I off camera?
Yeah.
Okay, we recognize this as being an x to the first power, so this should be a straight line. Okay, here we've got an x to the second power, so that should be a parabola. So that could look like one of these top 3 points up here. Let's take a look. Okay, you could graph these on your graphing calculator and hit second calc intersect like we did at the beginning of the year. However, you're going to have to do this in the test without your graphing calculator. Okay, so notice that this one is equal to y. Notice this equation is equal to y. If they're both equal to y, they're equal to each other. So I can say right away that x minus 2 has to be equal to x squared plus 2x plus 7. And notice that I cleverly left room under my linear equation. It's linear if it is an x to the first power. Okay, and if it's linear, you see that line in there? That's going to be the graph of a straight line. Okay, and I left this room open underneath here, and you'll see why when we get to the end of the problem. Okay, now when you look at the equation, this is just algebra 1 from here. We have an x squared or bigger, so make your equation equal 0. I'd like my x squared to be positive, so I'll take everything to the right. My x squared is fine right where he's at. And again, he's a positive x squared. That's why I want things to be on the right. I'll subtract x from both sides. It'll give me a plus 1 of those x's. I'll add 2 to both sides. It'll give me a plus 9. And I have that equaling 0. So I have an x squared. Now I'd like to factor it. This does not factor, so it's time for the old quadratic formula. Here we go. The negative of b plus or minus square root of b squared, always minus 4 times my a times my c, divided by 2 times my a number, and I come up with this. Okay, now we should be somewhat happy. You're probably thinking this is ugly, but I'm happy with it. Notice this is a negative 36. So 1 minus 36 would give me a square root of a negative 35. As soon as we see a square root of a negative, that's an imaginary number. And we don't have any points on our Cartesian coordinate system that are imaginary numbers. So as soon as you get this, then the points of intersection are going to be none, or you can put no solution. That line and that parabola will not meet. That's going to look like this picture. The line and the parabola will not meet.
But you can't put does not exist.
The points of intersection do not exist. So D and E could work there. No solution, something of that effect for your answer there. Next problem. Okay, this time I'm going to do 2 parabolas. My first parabola is y equals x squared, y equals x squared plus 3x plus 1. My students made as many mistakes in their tests and quizzes as I do up on the board here, but they have a hard time passing this class. Hopefully they're more careful than I am. Okay, my second parabola is y equals 2x squared plus x plus 2. Okay, two parabolas, now to find the points of intersection. Again, notice that they're both equal to y, so we can set them equal to each other. So x squared plus 3x plus 1 has to equal 2x squared plus x plus 2. Natalie, do you see an x squared or bigger? Yes, you do. So let's make this equal 0. I'd like my x squared to be positive, so again, I'll take everything to the right on this equation. Put down my equal sign. I'll subtract x squared from both sides. Will give me one of those x squareds. I'll subtract 3x. Will give me a minus 2x. Okay, whose phone was that? Give it to Mrs. Begeman. Whoever's phone that was, hand it over. Oh, that's my phone. Okay, and then I'll subtract 1 from both sides. Will give me a plus 1. And now we have the equation equaling 0. This time I do not have to use quadratic formula because this will factor for us into x minus 1 times x minus 1. I could write that as x minus 1 squared, but no need to in this problem. There's my two solutions, but wait a minute. Okay, what are these guys? What are they? These are x numbers if I look up here. These are x's. Okay, so my x could be a 1. My x could be a 1. I only have to use it once. Go to your easiest equation and put that 1 in. Which would be into that equation. I don't know what y is yet. But if I put the 1 in, 1 times 1 is 1. Positive 3 times 1 is a positive 3. Plus that other 1. I'll get y equals 5. There is my y number. And that is the only ordered pair that's a good answer for both of those parabolas. It's the only one that's a good answer for both. If you had time on a test and your life depended on it, you could put a 1 in for those x's and see if you get a 5. You could put a 1 in for those x's and see if you get a 5, and you will. Okay, 2 more problems. Next one. Here's an x to the first power, so that'll be our linear equation. Later this year, we'll have an x to the first power, but it will not be linear because the x will be times the y. Okay, then that turns into a hyperbola for us, but that's going to be later this year. Okay, my second equation is going to be a cubic function. 2x to the third plus 7x squared minus 7x minus 29. Let me double check that I copied this correctly. Yep, we're ready to go here. Again, notice, Regina, both of these are equal to y, therefore they're equal to each other. So the x minus 1 must equal this cubic equation, this cubic function. I have an x squared or bigger, so I want to make this equation equal 0. Once again, I'll take everything to the right. My 2x to the third is fine. My plus 7x squared, he's okay. I have to subtract x from both sides. If I subtract an x, we'll have minus 8x. I have to add 1 to both sides. Be careful, don't make a silly algebra mistake when we're trying to do this pre-calculus. Talk to yourself. If I add 1 to both sides, we'll get a minus 28. Just watch, I'll make the next stupid mistake up here. Okay, we've got a cubic to solve here, to factor. There is no common factor. That doesn't have an x in it. I can't factor out of 2. There's no common factor. Let's try groups of 2 and 2. If I put these two together, a common factor is x squared I'd have to take it times a 2x plus 7. And there's my 2x to the third power plus 7x squared, exactly what I have up there. Okay, I can factor 2 out of these two guys, but bigger. Let's factor out a 4. And how about a negative 4? We'll call that a minus 4. When you factor it out, it's very similar to dividing by that. So that will be a 2x. If I factor out the negative 4, I'll have a plus 7. And easy to check again, there's my minus 8x. Yep. And then my minus 28. Good. I'm happy there. Okay, now you should really be happy when you look at this also. I'm not doing anything new. We worked on this before I left. Groups of 2 and 2. I'm really happy because I see those 2x plus 7s. So I'll factor that. 2x plus 7 out. If I factor out the 2x plus 7, I've got left x squared. If I factor out the 2x plus 7, I've got left the minus 4. There we're in pretty good business. Okay, another easy way to check is FOIL. Here would be a 2x to the third. Yep. There's my minus 8x. Got one of those. Plus 7x squared. There it is. And my minus 28, I see that back there. I'm in good shape. I love it when I have something 10 something equals 0. So x could be a negative 7 halves. Or over here, if I would add 4 and then take a square root, x could be a positive or negative 2. Okay, so that's what x could be. These are x's here. All I found is x. We'll go like this immediately. X could be a negative 7 halves. And I'll put that negative 7 halves in for this x. Okay, and what I prefer to do on this is just to go like this. Okay, now I've got 2 for both denominators, so negative 7 minus 2 would be a negative 9 halves. Okay, there's one point of intersection. X could be a positive 2. If I put the positive 2 in for that x, 2 minus 1 is 1. We won't do that. If I put the 2 in for the x, 2 minus 1 is 1. My y number would be 1. And finally, x could be a negative 2. If I put the negative 2 there, negative 2 minus 1 is negative 3. And there should be my 3 points of intersection.
Hey, I got the same thing.
A straight line and a cubic. Just got the same thing I did. Groups of 2 and 2, we like that one. That one's your easiest one, and that's what I would try first. You could try a rational root theorem on this, but believe me, if groups of 2 and 2 works, it's much, much easier on this problem. Usually I underline that one twice, my groups of 2 and 2, but there's a nice looking problem, in my opinion. Right, one more problem, then we're done making these videos. If I ever go to Germany again, I hope it's in the summer. So I don't have to worry about my students here when I'm gone. Natalie, how are the Green Bay Packers doing? Of course, she's answering this question in October, and it's only August the 10th for me here, so I hope they have a perfect record, like 0-6. That wasn't very nice. Okay, last problem. Everybody in Natalie's family is a Viking fan, except for Natalie. Okay, this problem. Here we have a parabola, here we have a cubic function. We'll find the points of intersection, just like every other problem here so far. They've both been equal to y. Okay, I think you're going to run into your homework a problem where it doesn't equal y right away. Well, that will be no problem for you. That's a problem, but that won't be a big mountain in front of you. Just make your equation equal y, then you can set them equal to each other. So here we go. They're both equal to y, so they must be equal to each other. So x squared plus x has to equal this cubic equation. take everything to the right. And as I look at that and I try groups of 2 and 2, it's not going to work for me. Rats. It's time for the dreaded rational root theorem. Okay, a rational root theorem. I'm always taking factors of my last number, the 12. 1, 2, 3, 4, 6, 12. Hopefully I don't have to go past the 2 or 3. Okay, my first coefficient is a 1. So those are my only possible rational answers. The only possible rational answers. Okay, I'm going to guess -1. I'm going to try a -1 and see if it's a good answer. I'm just guessing. Okay, your notation should look like this. I'm putting a -1 in for all those x's. I'll get -1, -2, +11, and -12. And I will come up with then 0 equaling, oh boy, -15 plus 11 would be -4. 0 does not equal -4, so -1 is not a good answer. Okay, I'm a bad guesser. Let's try another guess. I'm going to guess a -6. No, I'm just kidding. I like sticking with small numbers. I highly recommend starting with small numbers first. I'm going to try a +1. If I try the +1, I'm putting it in for each of those x's. I'll get 1, -2, -11, and -12. Whoops, +12 back. Whoa. Jessica, how did my +12 turn into a -12 all of a sudden?
So you're a knucklehead.
I'm a knucklehead. Thanks, Jessica, for pointing that out to me. That's a +12. The -1 wouldn't work anyway. Let me try that one.
But really, I wasn't paying attention either, so.
You didn't know I was that big of a knucklehead.
Right.
Okay, so from here, now I'm in good shape, because look, I'll get 13 minus 13 is 0. Okay, 0 does equal 0, so that means yes, 1 is a good answer. 1 is a good answer. Okay, so that means x minus 1 will be a factor if 1 was an answer. Okay, and now we can take x minus 1 and divide it into this to see what we have left. If 1 is a good answer, x minus 1 is a factor. If x minus 1 is a factor, we divide it into there. And you know how to do that using synthetic division. I'll copy down my coefficients. If I'm dividing by x minus 1, a +1 goes in the box. Bring your first number down. Jessica, multiply.
1,
Add.
-1,
Multiply.
-1,
Add.
-12,
Then multiply.
-12,
And add.
0.
Okay, and you should be happy because you got a 0 at the end. Okay, that means that's our remainder. And if 1's a good answer, then x minus 1's a factor. If x minus 1's a factor, we better get a remainder of 0. So here's what we have now. I don't want to lose this guy, this x minus 1. We found he was a factor. From here, this is an x to the 3rd power. We divided by an x, so that leaves me with an x squared. So I should have 1x squared minus 1x minus 12. And I'm going to put my equal 0 on the right side. It was on the left over here, but I'll put it on the right side over there, just for the reasons of room. I can factor this quadratic. I'll copy my x minus 1. Gave me a nice problem. That x squared minus x minus 12 factors for us. I love it when we have something times something times something equals 0. Cassie, tell me why I count that wrong. Cassie. Miranda, can you help her? Look what my direction said. Find the points. Did it say just find the x number? All I found is x numbers. My x could be a 1. So I'm coming back to here and putting the 1 in. I'll get 1 plus 1, my y number would be 2. My x number could be a 4. 4 squared is 16. 16 plus another 4 is 20. My x number could be a negative 3. That's my x number. I'll put it in for that x. Negative 3 times negative 3 is 9. 9 plus a negative 3 would be 9 minus 3 is 6. There's my 3 points of intersection, my x number and my y number. Okay, and that's what we're doing here with this homework number 31. And I will see you next week.
Over and out.